Alright, so this video is talking about reasoning with probability. I find the thing that throws students off the most when reasoning with probability is sometimes there's more than one right answer, which is kind of weird for students in math. They think that they should get one number and that's the end. But when we're reasoning with probability, we're just trying to make sense of the situation and use probability to defend our answers. But that doesn't mean we all have to have the same answer every time. So let's look at a couple of examples. So the first question is Dylan and Cade split the cost of a package of 5 passes to a climbing gym. Describe a way that you could fairly decide who gets the 5th pass. So this word fairly is the important part. We have to make sure that Dylan and Cade each have an equal chance of getting that 5th pass. That's what we mean by fairly. So they each get 2 passes to start. To decide who gets the 5th, well, there's a few ways you could do it. One way is you could flip a coin, and if it gets heads, Dylan gets it, and if it's tails, Cade gets it. Then each of them have a 50% chance of winning, so that's a fair way to choose. Another way that would be fair is you could roll a dice, and if it's even, Cade gets the 5th pass, and if it's odd, Dylan gets the 5th pass. So those are just a couple of examples of a way you could fairly decide. It can be anything you want as long as the probability is the same for Dylan winning it and for Cade winning it. So I would say there's a 50% chance of heads and a 50% chance of tails, so that's fair. There's a 50% chance of even and a 50% chance of odd, so that's fair. So you just have to be able to defend your answer using probability. So let's look at another example. So number 2 says that in addition to prizes for first, second, and third place, the organizers of a race, let's scroll real quick. The organizers of a race have a prize that they want each participant to have an equal chance of winning. So again, we want this to be fair. So we want to choose a winner for this prize where everyone has an equal chance of winning. But this time we don't just have 2 people, so flipping a coin doesn't really work. We have a ton of people. So I think probably the most common way of choosing a winner for a prize like this is to put everyone's name in a raffle one time. So if everyone's name is in a raffle and they draw 1, then everyone has an equal chance of winning. So that would be one fair method. You could maybe come up with another fair method. The only requirement is that each person has to have the same chance of winning. All right, looking at number 3. 2 teams are playing a game against one another in class to earn 10 extra points on an assignment. The teacher said that the points will be fairly split between the 2 teams depending on the results of the game. So if Team A earns 1,300 points, so I'm going to go ahead and write that down. Team A earned 1,300 points, and Team B earns 2,200 points. Describe one way, again, there could be more than one way, that the teacher could split up the 10 extra points. So I'm going to go ahead and start by finding what percentage of the points each team won. So if Team A got 1,300 points and Team B got 2,200 points, 1,300 plus 2,200 is 3,500. So there's 3,500 total points. So if I do 1,300 divided by 3,500 and 2,200 divided by 3,500, and I'm going to go ahead and find those percentages. So 1,300 divided by 3,500 is 37. So the Team A got 37% of the points. And then 2,200 divided by 3,500, Team B got 63% of the points. So if Team A got 37% of the points, that means they should get 37% of the extra points, which would be 3.7 points for Team A. And then the same thing with Team B, they should get 6.3 of the points because they've earned 63%, so they should get 6.3 points. They earned 37%, so they should get 3.7 points. So that's one way the teacher could fairly split it up, is by finding what percentage they got in the game and then giving them that many of the extra points. Number 4, of course, has a typo because I have a tendency for typos. So it starts with Jocelyn and McCall, and then in the middle of the question goes to Alexa and Sophia. So we'll just start with Alexa and Sophia. So we have Alexa and Sophia are at a yard sale. So let's make this Alexa and Sophia. And they find a box of 20 collectible toys they both want. They can't agree about who saw it first, so they flip a coin until Alexa gets 10 heads or Sophia gets 10 tails. When Alexa has 3 heads and Sophia has 6 tails, they decide to divide the toys proportionally based on the probability each has of winning under the original set of rules. How should they divide the toys? So if Alexa has 3 heads and Sophia has 6 tails, that means that they flipped their coin 9 times because they got 3 heads and 6 tails. So just like on the last one, I'm going to go ahead and find what percentage of wins each of them has. So 3 out of 9 is 33%. 6 out of 9, oh, sorry, not 33%. Let's see, 3 divided by 9, yes, 33%. And then 6 divided by 9 is 67%. So that would mean Alexa, this was Alexa, should get 33% of the toys, and Sophia should get 67% of the toys. Well, let's see if that divides out evenly. So 33% of the toys, and there's 20 toys. So I'm going to do 0.33 times 20, and that's 6.6. And then the same thing over here, I want 67% of the toys, so 0.67 times 20 is 13.4. So if we obviously can't really have 6.6 toys and 13.4 toys, so I'm going to go ahead and round these. So 6.6 rounds to 7, 13.4 rounds to 13. So one fair way to switch them is to say that Alexa gets 7 toys and Sophia gets 13 toys. So the most important part about answering these questions is just that you can defend yourself, so that you can show some work over here about where these numbers come from and that they match up with the probability that you found. So that might not be the only answer, but that's one way to go about answering the problem. Okay, and then the last question we're going to look at is Bernard and Braxton are fighting over who gets to pick where to go to lunch. They decide to roll a die to decide who gets to choose. Bernard says he gets to choose if they roll less than a 4, and Braxton gets to choose, this should say choose, those typos. Braxton gets to choose if it's greater than 4. Is this a fair way to choose? Why or why not? So in order to decide if it's fair, let's find some probabilities. So Bernard gets to choose if they roll less than a 4. So a 1, 2, or 3. And there's 6 possibilities, so Bernard has a 3 out of 6 chance of winning. Bernard. And then Braxton gets to choose if it's greater than a 4, so a 5 or a 6. So Braxton has a 2 out of 6 chance of winning. So Bernard has a 50% chance, while Braxton only has a 33% chance. So this is not a fair way to choose because Bernard has a greater chance of winning than Braxton does. Who only has a 33% chance. So I'm going to go ahead and look at the assignment that I'm going to have you do with reasoning with probability. So I just think the most important thing for you to remember is that there's not always going to be only one answer, and there's definitely not always going to be only one way to explain it. So if we look here on analyzing with probability, so ignore this part. I have you starting right here on this page. So decide whether each method is a fair way to choose a winner. So to do this page, you're going to do exactly what we just did with the Braxton and Bernard problem. Find the probability that each has of winning, and if their probability is the same, then yes, it's fair. And if your probability is different, then no, it's not fair. And make sure you just explain that answer. So that's all it's asking on these first ones. I think you can read through them and kind of decide for yourself. And then this one is more like the first ones we tried. There's different ways that you could, different processes that you could use. So the number one thing I need you to do while working through this assignment is to just really think about it and reason through it and then decide what you think the best answer is and go with that. And don't be too focused on finding the one right answer.